Okay, so now I'm going to talk about the difference between ideal op amps and non-ideal op amps. So if you have an ideal op amp, and you'll want to ask me, well, how is that possible? And I will say, I don't remember, but I do know how they work. Okay, so what you have is that you've got your V out, and you've got a voltage at the positive and at the negative, so we'll call that VP and VN. And you have a current, you have IN and IP. And what is true for an ideal op amp, let's say I've got VN right here, and maybe a resistor, and maybe a resistor here, that, and maybe a voltage source here, another, and a voltage source here, might have that. These two don't have to be the same in this instance. So what is true for an ideal op amp is that VN equals VP. So VN equals VP. They don't have to equal 0, but they are equal to each other. Now, IN and IP do have to equal 0. And so in this instance, well, I have a weird one here, but forget anything I'm going to make up is going to be weird, so just don't worry about that. So your current current into the positive and current into the negative both have to be 0. Now, it also needs to be true that this A is not the gain. So, and the pictures up above this, A is the gain. This A is not the gain. I'll show you what A is in a minute. A needs to be infinity, and there's a resistance that is infinity, and there's another resistor that's 0. And I'll show you what those are on the next slide. I'll show you what these things refer to. So right now I'm just giving you that information, and then we'll see what that is actually referring to. So here is a non-ideal op amp, and we can take a look at what these things are that I was talking about. So this resistance right here, in an ideal op amp, that Ri is infinity. So no current flowing here in an ideal op amp. In an ideal op amp, this R0 is 0, so no resistance. Obviously, neither of those two things is possible, so an ideal op amp is, an approximation. Now, this A being infinity, that's A is VP minus A times VP minus VN. Well, we said in an ideal op amp, VP equals VN. In a non-ideal op amp, VP is not going to equal VN. And so you would take this A and multiply it times VP minus VN, and that is what would get you V out. So in a non-ideal op amp, V out equals A times VP minus VN. Now, the other thing that is true is that you have some voltage source that is your power for your op amp. And your output voltage has to be between plus and minus that voltage. That's VCC. And so in this example right here, VCC is 10. So V out has to be between plus or minus 10. So if your A was bigger than that, if your A made it so that you thought you were going to have a V out of 20, you don't. You just have a V out of 10. So this sets your limit for what your V out can be. This is for a non-ideal op amp. And our first example is going to be, and here I have the notes for what these things are. So Ri is your input resistance. It should be high, at least 1 mega ohm. So we said in ideal, it would be infinite, but in a real one, it would be at least 1 mega ohm. Low output resistance, you just want to have as low resistance as possible. And you want to have that A be as big as possible, which is going to allow us to make the op amp.
question.
Yes.
For the, you said, which one sets the voltage again? Like,
A.
That, the
Oh, well, both of these do. Both of these do. So, V out has to be between VCC and minus VCC, and that is just given. So that's just, what it's plugged into. And then, that sets your upper and lower limits. And this would be what you can get based on A. And we'll see how we use this. And the next two problems are for non-ideal op amps and how you calculate these.
So if you have these, you can't go over 10, right? Even if you have a larger A.
That's correct.
You can't go over 10.
You can't go over 10, right?
And is that only for non-ideal?
No, that's always.
Oh, for ideal also?
Yes, yep. For ideal also, yep. Okay, yes.
So how is the A that you were talking about different from the A that was in the
So the A that from before is the gain, and that's you multiply times the input voltage, not VP minus VN. And that's what your circuits textbook called G. So it's a little confusing just because on this handout I'm using A in two different ways. So I will use G for gain and A for this the open loop voltage gain. The open loop voltage gain is A as opposed to the gain, which is G. Okay, so problem 1. Any questions from those of you who are on Zoom? Okay. So problem 1, and this is going to be just kind of a plug and chug now that you know the formulas. An op amp with an open loop gain of 1,000,000, remember we wanted it to be big, and VCC of 12, has an inverting input voltage of 20 microvolts and a non-inverting input voltage of 10 microvolts. What is its output voltage? So what this means when it says inverting input voltage of 20 microvolts, that means that Vn is 20 microvolts and Vp is 10 microvolts. The open loop gain, that's A, is 10 to the 6. So given this information, so we know it's non-ideal, because if it were not non-ideal, we wouldn't be given this open loop gain. We have that the output voltage is A times Vp minus Vn, or the output voltage is 10 to the 6 times 10 times 10 to the negative 6 minus 20 times 10 to the negative 6, which is 10 to the 6 times negative 10 to the negative 6, which is negative well, that's what I would think that it should be negative 1 to the 0, right? Am I crazy? Did I do something wrong? Yeah, I'm looking at the solutions, and the solution is saying negative 10.
Maybe that small surface must be.
So 10 times 10 to the I know it. Yelp. Must have made the same mistake. I did. Look. 10 times 10 to the negative 6. Okay. 10, so this is 10 to the 6 times 10 times 10 to the, yeah, this is minus 10 times 10 to the negative 6. Yeah,
You have to
yeah.
what's in front.
Right. And so now this is minus 10 times 10 to the 0, which is minus 10.
It would almost be a little easier to distribute the 10 to the 6 first.
Right, and then you'd see it there. Yeah. So this is minus 10 volts, and then we have to check. So is minus 12 less than or equal to minus 10 less than or equal to 12, because this is VCC. So minus VCC less than or equal to V out less than or equal to VCC. And it is. And so, if what we get is bigger than that, you say that it's in saturation. And so, because the absolute value of negative 10 is less than 12, it is not in saturation. That's 2 words, in saturation. You know, my first SI of the year is always like, I feel like I'm so scattered and disorganized, and then I'm recording this, I'm going to put it online, and I feel like everybody's going to look at it and say, oh, she's terrible. But, okay, questions?
For, what is VP again?
VP is when we're looking at our op amp, it's the voltage right here. It also would be called your inverting input voltage. You could also call it your positive input voltage. You could also call it V plus. So it's the voltage at this terminal right here. And VN is the voltage at the negative terminal. Also, I'm sorry, the plus is non-inverting and the minus is inverting.
That was a really confusing way to phrase the thing.
Yeah, it is. It's because it's, for some reason, inverting is more, is like the norm. It's not, I mean, why, there's no real reason, but that inverting is more the norm. Because I think if you look at your most simple op amp, not this one, but this one right here, the most simple one that does something, it's inverting. And so you have inverting and then non-inverting. Okay, so now let's do our second non-ideal op amp. So for your non-ideal op amp, I found that with, I mean, I promised that I was not doing an electronics SI because I would have a lot of reviewing that I'd have to do before that. But I found when I did electronics, it was a lot of knowing what situation am I in and what equation applies to that situation, because you have these devices and you have different conditions under which it operates, like in saturation and not in saturation. And you're going to see that, and that's going to be key to understanding, you know, what is going on here. And so one of the things we're looking at is, you know, is our op amp in saturation or not? So what is the output voltage for an op amp whose non-inverting input, so that's VP, is connected to ground, so that's 0. Its inverting input voltage is, so that's VN, is 4 millivolts. Assume that the op amp open loop gain is 2 times 10 to the 5th, and its supply voltage is 10 volts. Okay, so we know that V out equals A times VP minus VN, or V out equals 2 times 10 to the 5th times VP, which is 0, minus VN, which is 4 times 10 to the negative 3. Or V out is negative 8 times 10 squared, or negative 800. Well, negative 800 volts, that is certainly smaller than negative VCC, and because VCC was 10, that's smaller than negative 10. So it is in saturation. And the answer to the question is that V out equals negative 10 volts. Okay, questions on that before I'm going to stop and save, and then we'll do some ideal op amps.
Why does it matter if it's in saturation or
Okay, so, like I was saying a minute ago, what you're going to be learning about in electronics is how devices operate under different conditions. And so when it's in saturation, it's operating in a different way, and I honestly don't remember what way that is. But that's why it matters, because it's doing something different when it's in saturation. And also, when you know when it's in saturation, you know what its voltage is. You know, it can't change. It can't get any more or less.
Okay, so again, non-inverting is positive voltage and inverting is negative?
Yes. Just remember invert, the invert part means negative. So invert is negative, so non-invert is non-negative, which is positive.
Yeah, and non-inverting is like a double negative.
That's right, double negative.
Okay, that's good.
Yep,
Actually.
yep.